For like our moles, it is more hydroxide because it's in a 2-to-1 ratio.
Yes.
So if there was 0.2 moles of KOH, then they would have the same basicness, right?
Yes. Yep. Okay. All right. Let's look at 4.31. All right. How we doing? Good? All set? So, first thing, what's a monoprotic versus a diprotic acid? One hydrogen, yep. And diprotic is 2 hydrogen. So as simple as that. Just the number of hydrogen, right? Can you have a triprotic?
Yes.
Yeah.
H3PO.
Right? H3PO4. Yep. So so that's just as basic as that. What's the difference between a weak acid and a strong acid?
Weak acid will not completely dissociate, and strong acid will.
Yes, right. Strong acids would virtually 100% ionization versus weak acids, which is less than that. Okay, much less. All right, and then the last one, simple, straightforward. Difference between an acid and a base.
Acid produces hydrogen ions in a solution. Base produces OH ions.
Yep. So again, acid produces hydrogen ions, base hydroxide ions. Straightforward. All right, let's look at 438. So 4.38 right now. And we're just going to go through those together. So as we go through them, think about it. It shouldn't take very long to do. But let me move this over. So it's asking us to classify each of these solutions as a non-electrolyte, a weak electrolyte, or a strong electrolyte. So HClO4. All right, perchloric acid, right? So per is one of the strong acids, so that is a strong electrolyte. Next one is HNO3. What's that? That's nitric acid, yep. So that's a strong electrolyte. Very good. NH4Cl. Well, how about this, right? What do we know about NH4? It's soluble. So since it's soluble, how do we have to treat it? We have to treat it like a strong electrolyte, right? Remember, if it's a soluble compound, it's going to form ions in water. And if it's a soluble compound, right, and it forms ions in water, then that makes it a strong electrolyte. The only thing that would make it a weak electrolyte is if it only partially formed ions in water. Okay, and those are your weak acids. You know, there are some like, and not that you have to know this now, but certain compounds are only slightly soluble. But we're not worried about those, okay, because of the solubility rules we use. How about CH3, COCH3, which they tell you is acetone? Okay, so what do you think that compound is?
It's a non-electrolyte.
Right, so, right, if you look at the structure of it, right, the fact that it has CH3 on both ends, right, means that it is a nonpolar compound, okay? And so if it's a nonpolar compound, what should we expect from that? Right, yeah, it's a non-electrolyte. As a nonpolar compound. All right, how about cobalt sulfate, COSO4? Strong, right? Because again, it based simply on the solubility rules, right? Actually, no. See that would be an exception. But anyway, it is a strong one. I was looking. It's technically that doesn't fit our solubility rules, but it is soluble and it is a strong one. How about sucrose? Non, right? Because it's a molecular compound. All right.
So do we have any weak electrolytes then?
So in that selection, no. They're either strong or non.
So you know how B is HNO3? What if it was HNO2? Then would it be considered a weak?
Yes. Yeah. If B read HNO2, which is nitrous acid, then it would be a weak electrolyte because it's a weak acid. Okay. All right. Let's look at the next one, 439.
C one of the complex.
What's that?
Is C one of the complex ions?
No, only because they don't tell you that is,
In excess.
yeah.
Okay.
All right, so I realize I'm looking at A now, and CaBr, calcium bromide, is soluble, and it's an exception. It doesn't fit our usual solubility rules. So we're going to ionize calcium bromide. Did anyone do that already or no? Do people ionize calcium bromide, or do you make it a solid precipitate? Yeah, so ionize that, and then we'll look at what we get. Because again, it doesn't fit the classic solubility rules that you need to know. It's an exception.
Well, something like that would be on our test.
So yeah, I wouldn't give you something like that. So if we just if we look at that first one, where we have HBr plus calcium hydroxide, because the calcium bromide is ionized, what is the net ionic?
2H plus 2H. No.
Yep.
Yeah,
Two hydrogen ions plus two hydroxides gets us two waters. If we look at B, right? In B, what are we going to get there? So we're given copper. You know what? There's another. Sorry. I'm pulling out all the ones that have the exceptions in them.
Hydroxide soluble, right?
So copper hydroxide is solid, so you have to write it just how it is. So it's CuOH2. You can't touch that, okay, because that's solid. But HClO4 is perchloric acid. So we have H ions plus chlorate ions. And when you do this, you're going to get water, and you're going to get copper chloride with copper perchlorate, which is actually soluble. Again, I've failed in the solubility rules with trying to stick to that, the case there. So in this case, right, if the copper perchlorate doesn't show up on the other side, how much of it do we have to include?
Just the copper.
Yeah, just the copper. So technically, the perchlorates cancel each other out, okay? Because they're ionized on both sides. So your final ionization looks like is copper hydroxide, solid, plus two hydrogen ions, gets you two waters and a copper ion. That's the final line. So two waters and a copper ion.
What's 2 plus, right? 2 plus ion?
Yep, 2 plus ion, yep.
Is that aqueous?
That's aqueous, yep.
Copper's aqueous?
Copper's aqueous.
For water, you can write liquid, right?
Yep. Liquid for water and aqueous for copper.
2H plus 2H.
All right, if we look at the next one, aluminum hydroxide, right, plus nitric acid, okay? Because it's solid, you have to keep the aluminum hydroxide together. Because it's solid. But the nitric acid, because it's a strong acid, you can ionize that. And what you end up getting is what?
Water and aluminum ions.
Yep. Water and aluminum ions, because the nitrate ions that form cancel. So you lose